Good day. I am Principal Alejo and I will discuss about the quad antenna. In my introduction, we will discuss the history of quad antenna. The quad antenna is a development of several inventions. The first inventor is Moses Jacobson. In 1924, Moses Jacobson patented a loop antennas with rhombic shape. A rhombic antenna which is made of 4 sections of wire suspended parallel to the ground in a diamond or rhombus shape. Each of the 4 sides is the same length, about a quarter wavelength to 1 wavelength per section, converging but not touching at an angle of about 42 degrees at the fed end and at the far end. The length is not critical, typically from 1 to 2 wavelengths, but there is an optimum angle for any given length and frequency. A horizontal rhombic antenna radiates horizontally polarized radio waves at a low elevation angle of the pointy ends of the antenna. Next is George Brown. In 1938, George Brown patented a loop antenna with rhombic shape and quarter wave sides. Its beamwidth can be narrow or broad, depending primarily on its length. The shallow radiation angle makes it useful for skywave propagation, the longest distance mode for shortwave, in which radio waves directed into the sky at the horizon reflect from layers in the ionosphere and return to the far beyond the horizon. Next is Clarence Seymour. In 1951, Clarence Seymour, W9LZX, a Christian missionary and engineer at HCJB, developed and patented a 2-turn loop antenna that he called a quad. He developed this antenna to resolve issues caused by large coronal discharges while using a beam antenna in the thin air of higher altitudes. Moore describes his antenna as a pulled open folded dipole, while the main point of Moore's patent was the 2-turn single loop design, which is not the antenna turned quad today. The patent does include a mention and illustration of a 2-element unidirectional quad, and describes the time when the full wave loop concept was developed. Moore's design eliminated interference from coronal discharge and effect, which is inherent with diode, is absent in a quad because its elements have no ends. But other advantages appeared. The higher impedance mentioned in the quote above translate to lower current and thus lower loss on the transmission lines and gain in higher that of a Yagi. Next is James Sheriff McCaig. In 1957, James Sheriff McCaig patented what we know as a cubical multiband quad antenna. These antennas often use designs where one part of the antenna is active for one band and another part is active for a different band. A multi-band antenna may have lower than average gain or may be physically larger in compensation. Next is Rudolf Baumgartner. In 1960, Rudolf Baumgartner patented the Swiss quad. This antenna, designed originally by HB9CV, has not yet received widespread attention in the Western Hemisphere. Measurements made by the designer indicate that its performance is superior to the conventional 2-element quad, while the structure is much simpler and sturdier. Next is Werner Bolt. In 1969, Werner Bolt invented the DJ4VM quad. DJ4VM quad had 2 central fed elements with this design. It needed a double matchbox with pacing lines for the feeding and was difficult to build and more difficult to tune. And lastly is Hans F. Ruckert. In 1971, Hans F. Ruckert invented the monolith tri-band cubical quad. A tri-band cubical quad has more gain than a 3-element Yagi. However, adding quad elements produces diminishing returns. And now, we will discuss the main topic, which is quad antenna. Quad antenna. The cubical quad or quad antennas traditionally not been as widely used as its more popular cousin, the Yagi. However, the cubical quad beam antenna is able to provide some advantages in a number of circumstances. Since its first introduction in the 1940s, the quad antennas found uses in a number of areas. It has been used for some television antennas, but it has also seen a lot of use within amateur radio applications for use at HF and VGF or UHF. Although the cubical quad antenna is not nearly as widely used as the Yagi, it still has advantages and can be used to good effect in many instances. Quad antenna basics. The quad element can be seen to be derived from two dipole elements, stacked one above the other and fed in phase. This arrangement in itself gives gain because of the pacing effect between the two dipoles. The next stage in the evolution is to retain the two separate dipoles but bend the ends together. It is found that voltages at the ends of the antennas are in phase with one another. As a result, it is possible to connect these ends together and remove one of the feeders to create the basic quad element. As such, the loop forming the element is a full wavelength with each side being a quarter of a wavelength. Development of the cubical quad antennas. The cubical quad is constructed by having an X frame made from insulating material, even wood, and then using this support the wire or tube that forms the conducting radiating element. In some instances, where antennas are small enough and the tubing is sufficiently robust, it is possible to rely on strength of the tubing alone for the mechanical strength. This is normally only achieved at VHF or better still UHF. Next is basic cubical quad antennas. Although the format of the Next is basic cubical quad antennas. Although the format of the horizontal square for the cubical quad is the more obvious format and the more common, it is also possible to turn the square format through 45 degrees. When this format is used, it should be remembered that the width of the antenna is equal to the diagonal of the square, whereas when the horizontal square is used, then the width is equal to only bottom of the square. Cubical quad antennas formats. The diamond style construction can provide an attractive option for construction. One point to note when using this configuration is that the two side mounting points labeled A for the wires are at the voltage maximum points. Points marked B form the current maximum points. For higher power levels, it may be necessary to utilize some form of proper insulator at the voltage maximum points. Cubical quad advantages and disadvantages. Since the introduction cubical quad beam antenna, there has always been considerable debate about its advantages compared to the more familiar Yagi. As with any antenna, there are always advantages and disadvantages that need to be balanced to see what is the most attractive option for any given situation. For the advantages of cubical quad, first we have gain. The cubical quad beam antenna offers about 2 dB over a Yagi of a similar length. This means that the quad compares to a pair of stock Yagis, as there is always some loss in the feed arrangement for stacking the two antennas. Second is low angle radiation. The fact that the quad antenna is effectively a pair of stock depots, it offers a lower angle of radiation than that provided by a single Yagi. It compares to a pair of stock Yagis. Third is effects of the close objects. The quad antenna is less affected by nearby objects, giving it an edge over the Yagi in many installations, especially those that are inside, possibly in the loft or attic. And lastly is the internally stackable. One advantage of the cubical quad antenna is that it is possible to internally stack separate quad antennas for multiple bands under some circumstances. This option is used mainly on the HF bands. For disadvantages of cubical quad, first we have construction. The construction of the quad antenna is not as straightforward as a simple Yagi. It requires a more complicated form of construction. Second is cost. The more complicated construction often results in higher cost for a quad than for a Yagi. This has meant that for commercial VHF or UHF operation, it is rarely used. That said, for amateur radio HF operation, it enables homemade construction with wire to provide some cost-effective installations. And lastly is the robustness. The quad antenna is larger than its equivalent Yagi, and the spider arrangement used on many HF bands is often not as robust as a Yagi. For the summary of quad antenna, the characteristics of the cubical quad mean that it is used in a number of situations. It was popular some years back as a UHF television antenna, but now it is less widely seen. It is still used for the amateur radio operation both at HF and VGF or UHF, where its features bring several advantages. Now, before I end this video presentation, I have here a simple 5 multiple choice questions that I've gathered related to my discussion. Thank you for listening. I hope you learn on what I discussed. That's all. God bless.